Okay, great. This is chapter 6, section 3. A lot of definitions here for quadrilaterals and parallelograms. So let's go ahead and let's get these theorems written down. Remember, you don't have to do the numbers. Okay, so if you can just write these down, and then I'm going to go ahead and draw pictures to kind of illustrate each one. And just please remember that if I'm going too fast, just stop the video, pause it for a sec, and then hit play once you get caught up. Okay, so be prepared to draw something that goes with it. All right. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So that's a converse of what we got in the last section. Okay, so it's just saying if you can prove that both pairs of opposite sides of a quadrilateral, remember quad means 4, if both sides are equal, then you can say it's a quadrilateral. If both pairs are congruent, then you can say it's a parallelogram. Doesn't mean all sides are equal, but it's a parallelogram. So once again, I go back, I use a square in the last section. In a square, are both pairs of opposite sides congruent? And they are. And if they go a step further, they're all equal, all 4 of them. Well, it doesn't need to be all 4, it just means opposite sides are congruent. Then I can say it's a parallelogram. So we're kind of doing the converses of what we did last section. In the next one, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then it's parallelogram. So remember, consecutive is same side, interior angles. Okay, remember with a parallelogram, you think transversal now, and we kind of expanded our thought process to include same side interior angles, which are supplementary, they equal 180. Okay, so this is kind of a different drawing here. Here's my parallelogram, and I've got an angle, let's call it X. These two angles in a parallelogram, if I go by my rules I know about a parallelogram, they should be congruent. So in both cases, I can go X plus Y is equal to 180. It doesn't matter which Y I'm talking about because both the Y's should be the same measure. So I could go supplementary angles this way, or I could go supplementary angles that way because of my rules of parallelograms. Okay. Now that one though, you have to be able to prove that they're going to be supplementary with the angle X. Okay, the next theorem, if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So we did this before, but now I'm using, if I can prove that opposite angles are equal. Okay, and remember, you got 2 pairs of them. Okay, then you can call it a parallelogram. Okay. The next one, if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So remember what bisect means, it cuts it into equal halves. So if I got a diagonal here and then a second diagonal here, if the diagonals bisect each other, that means that this side, that piece is going to be equal to that piece. And then this piece is equal to this piece. If I can prove that, then it's a parallelogram. Okay, then the last one, if one pair of opposite sides of a quadrilateral are congruent, should be E in here, are congruent and parallel, then it's a parallelogram. So if you had a parallelogram, and if you could prove that one pair, doesn't matter which pair, so I'll just go here, if they're congruent and parallel, then you can call it a parallelogram. Okay, no, so I could have it the other way. If these are parallel and these are congruent, I can call it parallelogram. So I only need one pair to be able to do that, or say that, to prove it, that it's a parallelogram. Okay. All right. So we got all those. They're converses of stuff. If you studied the previous section, that section should kind of ring a bell. It's the same. So we flipped it all. Okay. If you could draw questions A through E and mark it all up for me, And then we need to decide if there's enough information to tell if it's a quadrilateral, if the quadrilateral is a parallelogram, and then we need to be able to explain our reason and write. We want to write the theorem number from above. I don't want you to write the theorem number. I just want you to be able to just briefly write it out in words what the theorem says, okay? So once again, you know, I'm going to go quick. So pause it if you need to. Those should be arrows. And so if one pair of sides, opposite sides are congruent and parallel, then it can be a parallelogram. So congruent sides and parallel sides. I only needed one pair. I got my one pair. Okay. B, opposite sides look to me like they're congruent. So both pairs opposite sides are congruent. Okay. Okay. In this one, really not one of the theorems we have. I got one pair of opposite angles are equal, but they're on different sides. I could go reflexive right here. So that's equal. So I think I can just prove it by angle, side angle, but that's not one of my theorems that we had before, but I can prove it that way. All right. Then I could probably use some CP/CTC to prove like this side's equal that side, this side's equal this side, and that these angles here are going to be congruent. So, but that I couldn't prove that by one of the theorems that we had. Okay. In this one, a lot of kids want to say it's that last theorem, kind of like the one we had here, but it's not. This side's equal, and then this is equal or parallel. I could go transversal here. I could say that, you know, these should be congruent. I might be able to go here and do some stuff saying that these are congruent, or not. Not congruent. 180 supplementary is what I meant to say. Sorry about that. I could do a whole bunch of stuff there and maybe get there, but I don't think I have enough information there. I definitely can't use one of the theorems above. So I'm just going to say not enough information. Good. This last one, you know, these are, if it was a parallelogram, those two angles should be supplementary, and they are. These two angles should be supplementary, and they are. And so that's going to be the same side interior angles are supplementary or equal 180. Okay. And remember, they use the word consecutive. It's the same thing. Okay. All right. So there you go. Okay, you guys go ahead and draw yourself a graph, and if you can go ahead and plot those 4 points for me, please. And let me just double check my notes. Make sure that I did this. We got the same points here. And we do. Okay, so go ahead and plot those points on the graph. And label them with the letters too, please. Connect them. And they tell me that they're vertices of a parallelogram, so I'm going to use all that stuff. So I got A, I got B, I got C, and I got D. Okay. Okay. We're going to use something called coordinate geometry. Okay. Coordinate geometry means that I'm using points on a graph typically, and I'm going to use some specific rules and formulas to be able to prove stuff in geometry. In this case, I need to prove that this is a parallelogram. Okay, these are vertices on a parallelogram, but I have to prove it's a parallelogram. So there's a couple things that we could do here. But the one thing I could do is Pythagorean theorem. So I'll write that down. We haven't really talked about that too much lately, but it's coming back. The other thing we can use is the distance formula, which is this. Or you could have it, you could flip these inside. Okay. It doesn't matter how you do it, just as long as you do it the same to both sets of parentheses. Okay, and you're taking the square root of that as you're done. Okay, so let's do this the easy way first. I need to, in a parallelogram, go back over my rules. Opposite sides should be equal. Diagonals should be bisecting each other, so they should be equal lengths or sides. Okay. Opposite angles are equal. I really can't do anything with angles here. So I'm really going to stick with opposite sides being congruent. Okay. Typically in the old-fashioned days, we'd use a distance formula, and that's not a whole lot of fun because there's just a lot of math there, places to get screwed up, and I got to take the square root at the very end. But I want to point something out here too. If you took this side AB and you did this, did I draw a right triangle? And so hopefully you said yes, because I could use this side here and I could call that my C, and now I could use the Pythagorean theorem to be able to do it. And I think that's a much more friendlier way to prove that stuff is equal. Okay. And we're going to have to prove that I think that these two sides are equal. And I think that this side, BC, is going to be congruent to this side, AD. Okay. But I'm going to have to use coordinate geometry to prove that. Okay. So let's use Pythagorean theorem. Let's start here where I began. And I got to find the lengths of the sides. And I said that this side's my C, mostly because it's opposite the right angle. Okay. So count your squares. My A is usually the short side, so my A is 1. My B is 1, 2, 3, 4. Okay. And it equals C squared. Okay. So doing my math, I get 1 plus 16 equals C squared. 1 plus 16 is 17. Take the square root of 17, and I believe I get 4.2. I think it is. Let me triple check that. Hold on for just a moment. It is 4.1. Okay. So what I need to do is I need to go over to the side that I'm assuming that these sides are going to be congruent. Okay. So once again, count. This is 1 here. This looks like it's 4. So 1 squared plus 4 squared. This still would be my C side equals C squared. I get 1 and 16, C squared, 17 equals C squared. Take the square root. Hey, I got the same thing. So those two sides are congruent. Great. Okay. But remember, you got to have two pairs of opposite sides. So I'm going to have to repeat the process at this piece down here, the bottom, which is AD, and see if BC is the same. Remember, all the sides of parallelograms should be the C because my right angles are out here. Okay. So once again, let's go ahead and I'm going to go back and label this so we don't get messed up here. This was AB. This was CD. So I'm looking for BC. I'll come on. See, I got some room over here. BC. So I'm going to count squares again. The short side right here is 2. The long side is 1, 2, 3, 4, 5. So plus 5 squared equals C. Okay, so 2 squared is 4, 5 squared is 25, equals C squared. 4 and 25 is 29. And I'm going to go ahead and take the square root of 29, and I get 5.4, and that's rounded. Okay. So that's BC. So I need to go and find AD. So let's come up here and repeat my process. Once again, look at, I think that's 2. I'm counting squares. I believe that's 5. So, right here, I could go, hey, I'm getting the same stinking thing that I got before. I should be correct. I'm just going to be right and do it all the way through. 0.5 gives me 29. Take the square root of that, C equals 5.4. Okay, so that just proves now that all four sides are, or at least the opposite sides are congruent on all four sides. Okay, the other thing you would want to do too is you want to look at, and I know I got a mess here, so I'm going to do it in a different color. This side right here and this side right here, if they're parallel, they should have the same slope. Okay, so in this case, and my slope would be negative, I'm going down 1, 2, 3, 4 and over 1, so -4 over 1, or -4 for my slope for that, and I should get the same slope over here, and I go down 1, 2, 3, 4 over 1, I get the same thing. So that proves that they are parallel lines, and if they're parallel, and we already proved that they were the same length, then I only need one pair of parallel sides and congruent sides to prove it's a parallelogram. Okay, now I just want to be really upfront with you. Using the Pythagorean theorem was way easier than using the distance formula. So I drew in little right triangles to help you show you that. Really want to kind of stick with, if you have to find distance, make little triangles and use Pythagorean theorem. Okay, much easier than using the distance formula. Also, slope, just you got to remember, it's the rise over the run. You're going to need to use that too. I had to use that to really make sure that they were was really parallel, but I did all four sides, so that was enough right there. Okay. All right. So that took us through the end of 6.3. Make sure that you got that little hint down with Pythagorean theorem. Make sure that you got these are just the converses. So if you did a good job on the previous section, these shouldn't have been that difficult for you. But applying it now is what you have to be able to do. Okay.